Okay, so here is the list of images that I received. There are 102 of them, and when I pull up the known objects, I get a list of several asteroids in the field of view. Now, of course, most of these will be fainter than the limiting magnitude of this instrument, but if we go ahead and click through them, then we can see that some of them may be visible. So if I want to, I can add a track navigator just to do a quick inspection. So if I double click on it, then we get this animation. Now what I want to do is adjust background level to automatic because these images have not yet been normalized. So if I do that, you can see it better. So normalization, as it refers to in this context, is where each background level of each image is normalized, so such that they are equivalent. Anyway, that's something I'll show in just a moment, but for now, just looking through this list of known objects, so this one, magnitude 16.6, that's relatively bright. Next one here, if I wanted to, go ahead and do a view stacked image. So that's one example here. So just to get an idea of how many might we be able to view, I can do a sort by magnitude. So could we see a magnitude 19 object? So do a view stacked image. Maybe, possibly. It's pretty faint. So again, sorting by magnitude. If I want to look at this one here, mag 18.5, that one, again, similar. It's very faint, but possible. So I'm going to say that in general that there might be 1, 2, 3, 4, 5 or 6, maybe half a dozen that would realistically be detected by the tracker just based upon limiting magnitude here. Okay, so I'm going to go ahead and run the tracker. So go to Action, Synthetic Tracker. And again, I've not yet modified these images in any way, shape, or form. I've not done any normalization just yet. So I'm just going to show what that looks like, what kind of result I can get from just these original images here. So I'm going to run it on balance. I pretty much always run it on balanced preset. So that's a 50% sensitivity. That's really already quite sufficient for the vast majority of objects. So click OK. And I'm going to limit it to a motion of just the main belt asteroids, which is what those objects were to begin with. So a speed from 0 to 1 arcsecond per minute, and position angle from 200 to 300. So that yields about 550 motion vectors. So I'm going to click OK. And this will take a little bit of time just because these are 102 images and somewhat sufficiently large in dimension. But again, I have some acceleration taking place with the GPU hardware, so it'll run significantly faster than if it were on a CPU. So go ahead and give it a moment here to finish up. And as you can see, it came back with 3 detections. If I want to see what those are, I can load known objects. And I'm just using observatory code U69, which is somewhat close to Pasadena. So anyway, these are the identifications. So we have that brighter object here, the magnitude 16.6. So I can double click on it, and you can see that's the detection. And then I have another one here, and then finally a third one here. Now if I want to, I can also try to do a compute confidence. So action, compute confidence. And you'll notice it gives the first one a high confidence, and then the last two no confidence. And again, this kind of goes back to the normalization issue I talked about earlier. And so that also will play a role in how many detections it finds. So we've only found 3 here, but it can actually do a better job than this. So if I go back to settings, background level, change it back to manual, and as I scroll through the list here, you can see that each image has a different background level, and that will impair the tracker performance. So what I'm going to do is, I've already done it, I've already normalized these images, but for reference, you would go to Action, Calibrate Images, and then what you would do is check the box, Normalize Images. So it's a calibration routine, and then you would click OK, and it will proceed to perform that calibration. But just to make this a shorter video, I can go ahead and load up those calibrated images. So here are those images here, and I can go to load track. So I've already done a track with these normalized images, so I'll just go ahead and show you the result here. So here it is, and here are the detections that were returned, and here's the confidence of each one. Load known objects to see which ones line up with what has already been found before. So this returns 7 detections, which is actually, I mentioned before, about half a dozen would realistically be found, so that's in line with what I expected. So it got up to magnitude 18.8. So that one had no confidence just because it's a very, very faint detection, but you can just see it here in the animation. So I think this is actually performing as expected. This is detecting several asteroids in the field of view. So anyway, this should hopefully line up with what kind of results you would be able to achieve. So thanks for watching, and see you next time.